Hi friends, so far now we have learned the Laplace transform of some standard functions. Now these Laplace transform of standard functions we can use as formulae to find Laplace transform of other functions. Before we start to find the Laplace transform of other functions, let us quickly revise the formulae or what we learned in the last class. Here you can see that I have not written the answer. This is for you, that before I write the answer, you recall if you remember. The first is Laplace of e power at. This is 1 upon s minus a. Laplace of e power minus at. This is 1 upon s plus a. Now in place of a there could be any number. If it is 5, so you write 5 in place of a. Laplace of sin 80. This is a upon s square plus a square. Laplace of cos 80, it's s upon s square plus a square. Laplace of sin hyperbolic 80. Laplace of sin hyperbolic 80 is, again it is a upon s square minus a square. And cos hyperbolic 80, it will be s upon s square minus a square. So in hyperbolic function, denominator we have s square minus a square, and for circular function sin 80 and cos 80, in denominator we have a square plus s square plus a square and s square minus a square respectively. Now for t power n, we have seen two formulae. One formula is gamma of n plus 1 divided by s power n plus 1. This formula we use when n is a rational number. But if n is an integer, we can simply write this as n factorial upon s power n plus 1. Why? Because gamma of n plus 1 in that case will become n factorial. Laplace of 1, for getting Laplace of 1 in the above formula t power n, here we can put n is equals to 0. So we will get 0 plus 1, that is 1. Gamma 1 is 1 factorial. 0 factorial, and value of 0 factorial is 1. So I will get answer as 1 upon s power 1. So it is 1 upon s. Laplace of error function of root t. This is 1 upon s root of s plus 1. And finally, Laplace of complement of error function. So it will be 1 upon s plus 1, and then in another bracket we have s plus 1 plus 1. For error function, you can simply write this as Laplace of 1 minus Laplace of error function of root t also. So these are the formulas which we have already derived. We learn these formulas so that while we finding Laplace transform of other functions, we need not have to calculate these again. Now, along with these Laplace formulae, there are some other formulas that we should learn very well. So, some more formulae. First is definition of Laplace transform. So, definition of Laplace transform, what we have done, it is 0 to infinity e power minus st into f of t into dt. Now, this particular formula we are going to use whenever function f of t is given in 2-3 different forms for different values of t, which we have already seen while we are solving problems based on the formulas. Now integration of u into v. So integration of u into v, already we have learned that we can write this as u into v1 minus u dash into v2 plus u double dash into v3 minus and so on. Now here the choice of u and v, it is based on LIATE principle, and as we are solving the problems based on Laplace, here most of the time our one function is going to be exponential function. So that exponential function we always treat as v. So this v1, v2, v3, they are nothing but they are integration. Now integration of v is v1, integration of v1 is v2, integration of v2 is v3, and so on. So these are integrations, and this u, first we write u as it is, then we differentiate it, and then differentiation of u dash will be u double dash. While writing these formulas, we keep the values of v1, v2, v3 as we are getting it. That means minus sign if we are getting, so we first put them with minus sign, so that when we integrate that minus value, whatever value we should get, we get that value. We will not simplify the terms one here only. After writing the formula, then we can simplify. Now these are derivative terms. So this will continue till we get a constant value for this derivation of u. Now if we see this integration e power at into cos bt, here if I try to solve with the above formula, I will be in trouble, because when I take cos bt and start finding derivatives of cos, I will get sine, sine I will get cos, cos I will get sine, and so on. So it is a never ending process. Now this kind of problems we have already done in our previous standards. So here I am just putting the formula. The formula is, I write e raised to at divided by s, here I haven't written s, so it is a square plus b square. Now understand this a and b, what these a and b are. A is the coefficient of t in e power at, and b is coefficient of t in function cos bt. Now e power at upon a square plus b square, and here I will write a into cos bt plus b into sin bt. Similarly, for this e power at into sin bt, I will say that it is e power at upon s square plus b square, not s square, it is a square plus b square into bracket I will write a into sin bt, and minus, here keep in mind that here I am using minus, b into cos bt. Some values e raised to 0, so e raised to 0 is going to be 1, e value of e is approximately 2.7, so 2.7 power 0 is 1, e power not defined if I say, so it is 1 upon e power not defined, and the value I will get 0. Sin n pi is always going to be 0, cos n pi is going to be minus 1 raised to n. Now sin n pi 0, that means sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0. Here n is any integer number. And cos n pi, so it is minus 1 raised to n. So when I say that cos 0, the value of n is 0, therefore minus 1 power 0, I will get answer as 1. When the value of n is 1, it will be minus 1 power 1, which will give me answer as minus 1, and so on. Error function of root t. Now you rarely have to use the formula for this error function of root t, as already we have derived Laplace transform of error function of root t. But then also, if you need to derive, you should remember the formula. Error function of root t is 2 divided by root pi 0 to root t into e power minus x square into dx. Error function of root t plus error function of complement of root t error function, complement of error function root t is 1. E raised to minus x. Now there are some expansion formulas that we can apply, and this e power minus x, if I want to write using expansion formula, it will be 1 minus x plus x square divided by 2 factorial minus x cube divided by 3 factorial plus x raised to 4 upon 4 factorial and so on. Value of this gamma n plus 1, value of this gamma n plus 1 is n into gamma n, and if I expand I will get n into n minus 1 into n minus 2 and so on. So these are some formulas which we have used while finding the Laplace transform of these standard functions. Now trigonometric formulae, always I recommend that you learn all the trigonometric formulas. Okay, so there are many chapters in which we have to use these trigonometric formulas. Now here in this particular chapter, what trigonometric formulas are more important that I am discussing. So sin square x we can write as 1 minus cos 2x divided by 2. Now why I am discussing this formula? Because we have seen Laplace transform of sine, Laplace transform of cos, but Laplace transform of sin square x is what? So we first have to, or sin square t I will say, then we have to first convert this sin square t in the standard form whose formula we already know. So this sin square x can be written as 1 minus cos 2x upon 2. You can derive this particular formula from the formula of cos 2x, which is cos square x minus sin square x, and then we can change them in sin square term or only in cos square term, like that. Similarly, this cos square x, if we write this cos square x, so it will be 1 plus cos 2x whole divided by 2. Now sin cube x, to derive the formula for sin cube x, we must know what is the value of sin 3x. So I will start with sin 3x. Here I will write answer. So here I will write sin 3x. So sin 3x is 3 sin x minus 4 sin cube x. If I simplify this for sin cube x, so what I will get? Sin cube x is equals to 1 upon 4 I will say, and in bracket it will be sin 3 sin x minus sin 3x. Similarly, we can write formula for cos cube x. So before that, we see what is cos 3x. Cos 3x is 4 cos cube x minus 3 cos x. So therefore, the value of cos cube x will become 1 divided by 4. This 3 cos x will come on that side and will be 3 cos x plus cos 3x. Now see, this sin cube x is 1 upon 4 3 sin x minus sin 3x, and this cos cube x is 1 upon 4 3 cos x plus cos 3x. In the first part I have 3 cos x, and in the second part I have cos 3x. You try to understand how the placing of 3 is there, so that you remember these formulas very well. Sin cube x and cos cube x. Now sin power 4x and cos power 4x, if we have, then how we get these values? So there are two methods that we can use to find this sin power 4x and cos power 4x. And I recommend whenever they have asked you to find the Laplace transform of sin power 4x or cos power 4x, better first derive the formula and then use the Laplace transform. Now for this sin power 4x, as I already know the formula of sin square x, so I write this as sin square x. I write this as sin square x the whole square, and when I simplify I will get sin square x can be written as 1 minus cos 2x whole divided by 2 and the whole square. Now this 1 divided by 2, when I take out of this square term, it will become 1 upon 4, and this will be 1 minus 2 cos 2x plus cos square 2x. Further, if you simplify, you will get 1 divided by 4, 1 minus 2 cos 2x, and this cos square 2x again I can write as 1 plus cos 4x divided by 2. This 2 I will take out, so it will become 1 upon 8. This 2 will multiply here, so 2 and this 1, it will be 3 minus 4 cos 2x plus, so this is how we can find the value of sine power 4x. And similarly, you can do for cos power 4x. So cos power 4x, you can write this cos power 4x as cos square x the whole square. And this will give you answer as 1 plus cos 2x whole divided by 2 the whole square. And when you simplify, you will get 1 divided by 4, 1 plus 2 cos 2x plus cos square 2x. Now again this cos square 2x can be simplified. So 1 upon 4, 1 plus 2 cos 2x plus this I will write 1 plus cos 4x whole divided by 2. This will give me result as is equals to 1 divided by 4. I will say 2 plus 4 cos 2x plus cos 4x, 1 plus cos 4x, 1 plus cos 4x whole divided by, I will say 2. Now that 2 I will take out, and it will be 1 upon 8, 2 plus 1, 3 plus 4 cos 2x plus cos 4x. Now this sine power 5x. Sine power 5x, this can be solved as sin x into sine power 4x. Now we have already derived what is the value of sine power 4x. So I can say that this is sin x into sine power 4x. If I take the value of sine power 4x from here, it will be sine power 4x is 1 divided by 8, 3 minus 4 cos 2x plus cos 4x. So the value of sine power 5x can be written as sin x into 1 upon 8, 3 minus 4 cos 2x plus cos 4x. Now this 1 divided by 8 is constant, so I will write here this is equals to 1 divided by 8, we will take out, and we open this bracket, it will be 3 sin x minus 4 sin x into cos 2x plus sin x into cos 4x. So this is 1 divided by 8, 3 sin x I will write as it is 3 sin x minus sin a into cos b. So I have to apply formula for sin a into cos b. So it is 1 upon 2. We will discuss sin a into cos b later on, but here as we have this particular problem, so sin a into cos b, the formula is sin a plus b. So that will give me answer as sin a plus b, that is x plus 2x. It will be sin 3x sin a plus b plus it is sin a minus b. So x minus 2x is minus x. This is with 1 by 2 into. Similarly, plus I will use the same formula here. It will be 1 upon 2 into sin. If I add, I will get sin 5x plus sin of minus 3x. Now sin minus theta, we know that it is minus sin theta. So I will say that this is equals to, I have two terms with 1 upon 2, 1 upon 2. So better I multiply this whole inner side term by 2 and then take that 2 out. So I will get 1 upon 16, and here I will get something called 6 sin x minus 4 sin 3x. This is minus minus, so it is plus 4 sin x. Then this 2 already we have taken out, so it is sin 5x and minus sin 3x. This is equals to 1 upon 16, 6 sin x and 4 sin x. So if we club that, we will get 10 times sin x. Now this sin 3x and this 4 sin 3x, I will have minus 5 sin 3x, and lastly I have sin of 5x is equals to this 1 upon 16 sin 5x minus 5 sin of 3x plus 10 times sin x. What I recommend you all students, that you solve this particular formula yourself. I have given you an idea how to solve. You derive it, because whenever Laplace of sin power 5t is asked, you have to first show the value of sin power 5t and then you have to proceed further. Now in the above formula, already we have used this sin A into cos B. Sin A into cos B, I can say that this is equals to sin of A plus B plus sin of A minus B whole divided by 2. This cos A into sin B, it will be sin A plus B minus sin of A minus B whole divided by 2. This cos A cos B, it is cos A minus B plus cos A plus B whole divided by sin A into sin B, again it is cos of A minus B, and here it is minus cos of A plus B whole divided by 2. So here sin A into sin B is cos A minus B minus cos A plus B divided by 2. Then the formula you can write cos A plus B plus cos A minus by 2. But to make these 10 and 11th formula almost similar, I have used cos A minus B first. These are all the formulas that we must remember. There are some more formulas that we will see while we are solving the Laplace transform.